Magnetism and Electricity, Video 5. Investigation 4, Current Attractions. Hey, it's Nick Kapoor from the Winship School again, continuing the video series for the FOSS Magnetism and Electricity unit. The focus of this video is going to be on Unit Investigation 4, Current Attractions, which is broken into 3 parts and according to the teacher's guide, should take you between 3 to 5 teaching sessions of 30 to 60 minutes each. These are the student learning outcomes for the investigation, and again, you can see them at the Science Department Weebly site. For this investigation, you can remove all the bulbs and motors from the materials bags. Students will be investigating electromagnets, so you need to add 1 metal rivet to each materials bag, as well as 1 long 24 gauge thinner wire. You can check pages 8 and 9 of this investigation teacher's guide for materials prep directions. If you have clean, empty vials left over from other kits, you can distribute the small metal washers in the vials. It's also good to use full-powered batteries for the electromagnet investigations to make sure that they actually create a usable electromagnet. In part 1, students will build an electromagnet. I found that the teacher's guide, open-ended directions, do not provide enough structure for students who have no idea about electromagnets. I like to show this YouTube video of an electromagnet in action as a way to show that electromagnets use electricity to create a temporary magnet, and they can be turned on and off. I like to keep the volume turned down and say out loud, open circuit and closed circuit as the video is going on. Then I tell the kids that we are going to try and build a small electromagnet in the classroom. I know that this goes against the typical experience before vocabulary format that we try to use, but I found in this case that it both hooks the kids in and provides them with a background experience from which to draw while trying to complete the investigation. In my experience, students struggle with creating the electromagnet enough where I'll sometimes both show the video and give the hint that it's the electrical energy flowing around the rivet that creates the magnetic field. You will need to determine what level of scaffolding your class needs and read through this part of the investigation in the teacher's guide for different ideas. It's important at the end of this class to leave time to share results and discuss which designs were most successful. Designs where the wire is wrapped neatly in one direction, close to the fat end of the rivet, typically pick up the most washers, in my experience. Another place where children struggle is that they sometimes forget to connect the wire to the circuit. They get excited enough about the electromagnet where they leave one of the wires unconnected. So that's another place to look if students are struggling. In part 2, you'll specifically investigate how changing the number of winds of wire affects the strength of the electromagnet. Again, like the breaking the force investigation, you might want to have a couple of versions of the data table and graph based on your students' abilities, in particular the needs of your ELL and SPED students. You also might want to consider breaking this up into a day for data collection and a day for graphing and interpreting data if you have time. Students should find that the more winds around the rivet, the more washers the electromagnet can pick up. In part 3, students will investigate how to make stronger or weaker electromagnets. They might want to test coils that are not tight, like these ones, winds that are in both directions, like these ones, or add additional batteries that are either in series or parallel. As there's no new vocabulary or concepts introduced in this lesson, this is another activity that may be skipped or used as an extension to other lessons if necessary for time requirements. That's it for Investigation 4, Current Attractions. In the next video, we'll cover Investigation 5. Click it.